Hydra is a famous tool in the world of cybersecurity. Think of it like a skeleton key for digital locks. Its main job is to guess passwords very, very quickly. This process is called a brute force attack. Hydra tries thousands or even millions of username and password combinations against a login page until it finds one that works. It is one of the most popular and versatile tools for this purpose. It supports a huge number of protocols, so it can try to log into many different kinds of services. This flexibility makes it a must-have tool for penetration testers. The name Hydra comes from a mythical Greek monster with many heads. The tool is named this way because it launches many login attempts at the same time, a parallel attack. Hydra's power lies in its speed and concurrency. Getting Hydra ready to use on Kali Linux is incredibly simple. On recent Kali, Hydra is probably already installed. Kali is designed for penetration testing and includes hundreds of tools. Open a terminal, type Hydra, H and press Enter. If you see a long list of options, Hydra is installed. If it is not installed or you are on Debian Ubuntu, use the apt package manager. Update first, then install. Confirm when prompted. The process is automated and quick. Installation completes in under a minute on most systems. Verify by running Hydra H. You will see flags, options, and supported protocols. Seeing the help screen confirms a successful install. You are ready for the next steps. You have summoned the many-headed beast for ethical use. Using a tool like Hydra comes with great responsibility. It is vital to distinguish ethical hacking from unethical hacking. Ethical hacking is done with permission. A company hires you to test security, with a signed contract and clear rules of engagement. The goal is to find vulnerabilities and report them so they can be fixed. This is legal, valuable work that helps make the digital world safer. Unethical hacking, access without permission, is illegal, regardless of intent. Consequences include fines, prison, and a ruined reputation. In the US, the CFAA prohibits unauthorized access. Most countries have similar laws. Testing a site without consent is like trying a neighbor's doorknob. You are crossing a line even if you do not go inside. Always ask, do I have permission? If the answer is no, stop. Do not proceed. Only test systems you own or have written authorization to test. That bright line separates professionals from criminals. Build a safe practice lab and respect this boundary. Now that we understand the legal rules, where can you practice safely? Start with systems you fully own and control. Set up a lab using virtualization like VirtualBox or VMware. Virtual machines are isolated computers inside your computer. Install an OS, set up a web server, and create a login page. This becomes your legal playground. Use purpose-built platforms. VulnHub hosts intentionally vulnerable machines you can download and run. Live online labs also exist. Some require a subscription. If you are a developer, test your own site. Assess admin password strength and whether brute force protections exist. Be careful on shared hosting. Testing can impact others and violate agreements. Never point Hydra at public sites you do not own. Banks, schools, social media, or major platforms. They will detect and may report you. Stick to your own VMs, training platforms, and personal projects. That is the only way to learn without getting into serious trouble. Okay, let's walk through a simple, practical example of using Hydra. We are testing a login page on a web server that we own. Let's say the server is at IP address 192.168.1.101. The login form sends username and password via HTTP post. We suspect the username is admin, but we do not know the password. We have a list of common passwords in passwords.ext. Our goal, use Hydra to find the correct admin password from our list. First, gather info from the login form. 3 things matter. 1. The submission URL, e.g., login. 2. The username and password field names, user and pass. 3. The failure message shown on bad credentials, e.g., login failed. Open a terminal and build the command piece by piece. Call Hydra, specify the username with ladmin, provide the password list with ppasswords.txt, then the target IP 192.168.111111, and the protocol HTTP post form with the form string login.user. User and pass. Pass, login failed. Let's break down that long Hydra command. Every part is an instruction. Hydra, L-admin, P passwords.txt, 192.168.11.101, HTTP post form, and the quoted form string. Hydra is the tool you are executing. L fixes the username to admin. P tells Hydra to read candidate passwords from a file. HTTP post form targets a web form submitted via post, with login as the submission path. User and pass are replaced by guesses. The trailing login failed tells Hydra what response indicates failure. If it does not appear, a login likely succeeded. If any part is wrong, the attack fails. Get each detail right to make Hydra behave as intended. A brute force attack with Hydra is only as good as its word list, a simple text file with one candidate per line. If the correct password is not in your list, Hydra will never find it. A small, smart list often beats a massive random one. Kaylee includes word lists, most famously rockyou.txt, from a real breach with millions of real-world passwords. Unzip if needed, then reference it with p, usr, share, word lists, rockyou.txt. Many other lists exist online, some extremely large. But generic lists are not always best. Create tailored lists using recon, company name, products, location, important dates, and common patterns like company name 2025 or password 123. Tools like CEWL and CupEP can generate custom word lists from site content or target specific details. Combining a solid general list with a focused custom list increases success during authorized tests. Let's apply this ethically. You built a small site, blog, photo gallery, or a tiny shop with an admin login. You control the VPS and want to ensure the admin account is secure. Create an admin user and temporarily set a weak password to validate your defenses. Use a common list like rockyou.txt to simulate a low-effort attacker. Identify the submission URL, the username and password field names, and the failed login message. Build the command with your site's specifics, verify each part, and run it on your own server, within legal and ethical bounds. Hydra tries candidates. If your weak password is in the list, Hydra will find it and display the successful username and password. Seeing this as both a success and a warning, immediately change to a strong, complex password. You have seen how weak passwords fall. Now, how do you stop it? Start with a strong password policy. Long, complex, and unique. 12 to 16 plus characters, mixing upper, lower numbers and symbols. Weak passwords can fall in seconds. Strong, random ones can take astronomical time. Do not reuse passwords. Use a password manager. Implement lockout policies, e.g., lock for 15 minutes after 5 failures, slowing Hydra to a crawl. Add two-factor authentication, so a password alone is not enough. Codes from SMS or an authenticator app. Use CAPTCHAs to throttle automation, monitor logs for repeated failures, and block abusive IPs. Combine these layers to build robust defenses against Hydra and similar tools. Ethical knowledge used to protect, not to harm.